Ford totally transformed motor manufacturing, and new international players started calling the shots. Well, we're into that at the moment. The big IT companies are actually, international IT companies, are the ones that are calling the shots. And the question then therefore comes is, what are the design-led opportunities and what are the challenges that may be involved? And I think it's important to think about specifying the right design challenge. The transport disruption is actually playing out right across the design spectrum. It's playing it from product design, you've got elements of software design, you've got service design, and certainly manufacturing design is certainly in there, system design. It is straight across the design spectrum. But government and industry tend to see the challenges as largely at the product design level. If you get zero emission vehicles, you're addressing transport's big environmental emissions problems and global and climate change problems. Job done if you get everybody to drive around in electric vehicles. Once you start thinking that way, then you start where you focus things, for example, is electric vehicles cost a lot. How can we actually reduce the cost of them? Big subsidies, can you shove in loads of public investment for charging infrastructure? The question is, will the market actually shift? Is the personal purchase model, for example, the actual problem? Would a leasing model be more appropriate for a capital-intensive piece of technology? Or, that's what's happened with mobile phones, which we originally purchased, now are predominantly leased on a two-year contract, all-in contract, and so forth. These models, different service models, have appeared as innovations have come on the scene, and they have actually changed the key design questions. Or do you even go as far as an app-led mobility service instead? I think the real challenge is that the real design challenge isn't just about product technology, but on getting an appropriate service design for that technology and how that interacts with users. Now, I'm going to just talk through an example that we've been looking at in a book chapter put together, and also in a blog that's gone onto the Conversation site. And this is about public transport services and how these new technologies may affect public transport services. Now, the use of public transport is seen as crucial for sustainable mobility, and you see report after report talking about increasing public transport use as being very important. Now, you've had some big cities have got developed metro and tram services, but outside of these, you actually see that bus service is in steep decline. And despite however much money is thrown at it, and even when you sort of try and shift from the privatized bus services to nationalized services, that decline is continuing. When you look behind the figures and try and do a bit of analysis, you just look at what is happening at a systemic level. And the systemic cause is that fixed route bus services actually struggle to serve modern patterns of mobility demands. 21st century patterns of mobility demands are for very flexible moves. Travel demands are dispersed geographically. They're dispersed not only in space, but they're dispersed in time. They're dispersed across function. People often talk about metro systems that serve journeys to work, but even before the pandemic, journeys to work were a declining journey purpose. They were down to about 15% of all mileage. And if you have this obsession with the journey to work and getting people into workplaces and back, you're actually ignoring 85% of all travel. Most travel is actually related to our more complex, digitally based economy and society that we have today. And perhaps getting here to Coventry might be an example of it. And some of the patterns that emerged in the pandemic towards hybrid working, home working, or more flexible working patterns has only accentuated this sort of trend. And just making cheaper and more comfortable buses doesn't overcome a systemic service design issue. But there have been developments occurring. There have been, as a high-tech revamp for public transport, started. Sorry, I'm kicking the cables underneath the table and shifting the camera. We're okay. Some important developments are emerging. Top right, we've got their electric bus. I noticed at least 2 or 3 running around the streets of Coventry here. You've got information systems, increasingly just available on your phone. Bottom right is actually a trial. That's the MyLink bus, which is a driverless bus being trialled out in Abingdon. They've got one in Scotland as well. I think it's the bottom left that's quite the interesting one. If you just have a look at that picture, what do you think it shows? I'm asking the people in the room now. What do you think that shows?
Is it trackless tram?
Oh, you've got there far too quickly. Yeah, it is a trackless tram. Trackless tram. It's there's no overhead wires and there's no rails. It's guided using a mixture of LiDAR, GPS, and an optical guidance system. The optical guidance system follows those dotted white lines in the center, which can be overruled by the GPS and LiDAR, such as in this case where it's changing tracks. It's a Chinese development. It was first trialed, I think, in 2017. A year later, it went into service in 1 city in China. It's now in service in 6 cities in China. Very much cheaper to build. You don't have to dig up the roads and cause a lot of problems. You just allocate road space to it. You don't have to put in overhead wires because it actually uses automotive traction batteries, and it recharges when it reaches the stops. There's a contact point which recharges the batteries at stops. There's some really quite interesting stuff going on. And a lot of the challenge there is actually in the sort of what you might call the industrial design side of things. The Chinese were very clever in that they decided to mimic this, which is technically a bus because it runs on rubber tires. It doesn't run on rails. To create the same sort of image as you have for modern trams and modern sort of metro systems, to have the same sort of quality of service, the same sort of image, so that that actually helps the uptake of that. But these are really about product level designs. They certainly could revamp fixed route services. They would have big advantages. They can be introduced quite quickly. But although they'll address some of the problems about putting in public transport that can really work, there is an issue about, there is still this thing about modern mobility demands of being so much more dispersed than they used to be. And do you actually need to reinvent what public transport is? Now, there have been some attempts at doing this. Top right is a picture of the Heathrow pods. These are autonomous 4-seater pods that have been in service for about 15 years now, between car parks for Terminal 5 and the terminal, and they just come on demand. You don't have to wait for a bus. The vehicle comes when there's always a vehicle waiting there when you're there, and it will take you to whichever car park station you want or to the terminal. They run on segregated tracks, so you don't have any problems about running on mixed traffic, which affects autonomous vehicles on roads. The bottom picture is San Francisco Cruise driverless taxis, which have been running for a couple of years now. They are incredibly expensive to implement. And if you put a traffic cone on the bonnet, it gets terribly confused. And a lot of people have found that they can have a lot of fun with traffic cones in San Francisco and causing the driverless taxis to have a breakdown. It's coming, the autonomous stuff, but it is a rather susceptible technology at the moment. But there are ways of actually redesigning the public transport service as it is. And this is into the area of demand responsive transport. If you could think of what will be the ideal public transport system, it would be where I don't wait for a vehicle that may or may not come. I don't have to conform to a bus route, or I don't have to conform to a bus timetable. The system actually conforms to what I want to do. And that's the idea behind demand responsive transport. The concept has been around for 20 or 30 years. The technology has not been available to make this a cost-effective thing. That is now starting to change. So a couple of examples, I'm just quoting these, are Milton Keynes' MK Connect service and Hearts Links. MK Connect is Milton Keynes is essentially very suburban, very dispersed travel patterns. So if you think of it as a sort of suburban style transport system, that's how it works, and works quite well in that respect. Hearts Links is essentially a rural to urban service running in North Hertfordshire. And these both and others that are being developed operate in an Uber-like app. You just basically have your mobile phone app, you book a trip, and it goes from a pickup point to a drop-off point. It's not exactly from your home to a precise destination. It's more efficient if you have to travel a little way to be picked up. That makes it more economic for the way the system works. But the key thing is that you've now got all that software that's been developed for taxi companies, which Uber pioneered, and a whole load of others. The big IT companies have got this software and are very happy to tweak it and adapt it for a new market. And they're starting to adapt it for the demand responsive transport market. Because you operate using small vehicles, Milton Keynes has basically actually uses cars, you can see it in the middle there, or a van, which is maximum 8-seater. Links uses slightly larger buses, which I think are 12-seaters. But because you have small buses with a driver, and driver is a big cost, they do need a subsidy at the moment. But if you're looking at as an alternative to a route which is subsidized already, these services come out as costing less than a fixed route service. And instead of people only being able to go to somewhere on that route, they can actually go, in Milton Keynes, you go from anywhere in Milton Keynes to anywhere in Milton Keynes, same in North Hertfordshire. The trip opportunities are much bigger and relate far better to modern travel demands. These emerging products and services do have their strengths and their weaknesses. They are a different sort of service. They serve different sorts of people and different sorts of journeys than do traditional public transport. So we have to be very aware of the user within this. As I said, we are in a period of turbulence, both in the products providing mobility and their service systems, and behind that, the manufacturing systems that are involved as well. In ground transport, there hasn't been a position like this for over 100 years, not since the 1900s to 1920s, when the internal combustion engine replaced the horse. At that time, there were competing visions for future mobility, and today there are competing visions for future mobility as well. Competing in terms of technologies, in terms of service designs, in terms of how these affect people's lives, and very crucially, in how the sustainability impacts are created. It'd be nice to be a lovely futurologist and just say, this is how it's going to work out. but I think I know where I can do that. The journey has only really just started. And really what I'm trying to identify here is identify that what might be important factors in determining the final direction and the design-led opportunities that may arise. I've just put here, hold on tight, it's bound to be a bumpy ride, but I think it will be over the next decade or two. Thank you. We'll now move on to Miguel Valdez's presentation, and we'll have questions on both his presentations at the end. Thanks, Miguel.
Thank you, Steve. Hello, everyone. My name is Miguel Valdez. I am a lecturer in technology and innovation management. I came to the Open University lucky 13 years ago as Steve's student, as it happens. He was my doctoral supervisor. And then when that happened, I was here doing research on electric vehicles. After that, I moved on to working with smart cities. And now I am mostly about artificial intelligence in urban settings, particularly urban robotics, which is what my presentation will be about. I'll need just 1 second to load it. Please bear with me. Here we are, hopefully. There we are. My work is about the pandemic. Well, I think everyone is tired of hearing about the pandemic, but I would also say that a moment of crisis tells us a lot about how systems work. When things break, even when we as kids break my mom's alarm clock, for instance, to try to figure out how it works, it is very revealing, even if it is a bit painful, particularly for my mom in the case of the alarm clock, and for us as we have to live through the pandemic. But so the story, in 2018, the Starship grocery robots were introduced in Milton Keynes, where I live and when the central campus of the Open University is. And they were introduced to automate on-demand grocery delivery. I don't know if you have tried those robots. They are pretty much a tiny refrigerator on wheels. You think, oh, I forgot the milk, and I don't feel like going out in this weather. Robot, bring me the milk. And the robot goes from a shop close to you. It drives alone on the pavements, on the cycle paths, and it pings you on the phone. Oh, I am at your home. Please come open. I go off my front door. I tell the robot, I am here, please unlock. I open the robot, I get my milk, and the robot goes back to the shop, and I go back to making my breakfast. It was a bit of a novelty when it was introduced. A novelty, but by April 2019, they have completed 50,000 deliveries, which is not nothing. 11 months later, they have doubled that figure, 100,000 deliveries. And 3 days after the company said, yay, 100,000 deliveries, the lockdown was announced. Nobody saw it coming, or at least I didn't see it coming. I remember when they told us at the Open University, please don't come back tomorrow. We are going to have this pandemic. I thought, all right, we will be back next week. I think I even left milk in the fridge and everything. And well, didn't go well. But anyway, the point was, as service was introduced, just a bit of a novelty, and to reduce labor costs, because a robot is far more affordable than having people doing this kind of delivery. And then you have a crisis, and that changes how you see that service. In this case, you surely remember supermarket shelves were empty, and I don't drive a car. I usually get my grocery deliveries from man in a van, and it was impossible to do so at the time. I tried to order my groceries as usual, and they told me, if you are lucky, the next lot will be available 2 weeks from now. But the robots were still available next day, because a robot will not tell you, my shift is over, I am not legally allowed to drive anymore. The robots were operating 14 hours a day, and they were also free of face-to-face contact, because then the delivery driver had to figure out, how can I do my deliveries without exposing people to contagion without exposing myself to contagion. And the robot did not have that problem. And because of that, the amount of robots available for deliveries at the beginning of the pandemic was 30. After a couple months, it was 70. By July, it was 100 robots. This also because if you are trying to train a new driver, it will take the driver quite a while to figure out their way around the city. If you install a new robot, you connect it to the central server. We can think of it a bit of a hive mind, if you will, and the robot instantly knows how to move around the city, where it is supposed to go, how to balance the load management to say, if we have so many deliveries in this neighborhood, what do we need to do so we will have enough robots? All artificial intelligence, not very advanced artificial intelligence, but enough to know how to get from the shops to a certain postcode and back. And that was enough to cope with this emergency. Now the question is, how were these robots able to cope with this disruption? Because they were not designed to do so. But sometimes when the system is designed to be adaptable, you don't have to know what you are adapting for. You just have to know the system has this flexibility, it has this facility to learn, it has this facility to be adapted for other purposes. And you do not need to know if there will be a pandemic next year, or if it will be a snowstorm or a heat wave because of climate change. When there was a petrol crisis about 1 year after this, the company was also advertising, you don't have to drive your car to the shopping center and run out of petrol, and then you have to queue for days because you remember the petrol crisis as well, when you can just order this electric robot to bring you the deliveries. So the point is, the system was designed to be flexible, and you don't have to know, or you cannot know in advance even what it is flexible for. It just has that inbuilt flexibility. And I was wondering, as I was reflecting about this flexibility, if these robots were a force for continuity, or if they were a force for disruption. Because when they were introduced, the company thought, we are going to revolutionize deliveries. We are going to revolutionize the labor markets, because we are going to make, with inexpensive robots, the company tells me that they cost about as much as a laptop. And then you don't have to pay labor for any time after that. You get the robot, and that is, and they thought, we're going to revolutionize the cost structure of how we do deliveries to make same-hour deliveries to your home possible in a cost-effective manner. So they meant to be transformative in a way. And maybe artificial intelligence will be, but at the same time, it became a force of continuity, because when there was a crisis that was disrupting key urban flows, instead of being disruptive, this service allowed us to continue these urban flows. The groceries were flowing, maybe not delivered by humans, but delivered by robots, but the underlying flows were the same, even if the mechanism was different. So it was an almost autonomous reconfiguration. So everything changed, so everything could continue being the same in a way. Now, coming back to the idea of design, how do we design for humans and for robots at the same time? Thinking about the transport museum where we're at, when the car was introduced, lots of planners started designing cities for cars. And cities designed for cars are usually not good for humans. You cannot walk to places because they assumed in the 60s, for instance, when Milton Keynes was designed, they thought, oh, everyone is going to have a car. And because of that, it is very difficult to use public transport there. You cannot quite walk anywhere. But on the other hand, they designed Milton Keynes with cyclists in mind. It was leisurely cyclists. They thought people will have a lot of free time. They will use our cyclopaths, the redways they are called because they are all red tarmacs. They will use them for leisure. And you can see in those pictures with the one with the robots, that is a path for cyclists. And it turned out to be just the right size for robots too. They can navigate it very comfortable. These are segregated footpaths, so the robots don't have to worry about crossing traffic. And the robots, their artificial intelligence is not very good when crossing traffic. if they have to actually cross an intersection, they can sit there for 20 minutes before they will be brave enough, bold enough to cross, the poor things. But cyclists, they can cope with cyclists. So anyway, my point being, the city was designed with cyclists in mind 60 years ago or so when they were making these plans. Nobody thought someday a robot is going to use this. But as it happens, the city that is well designed for cyclists is also good for robots. So we don't have to design either or. How do we design for robots and then think, oh, we left humans out of the equation? We have to think about some nice coexistence. And I will move on to the principles of the new town. I think I am kind of overrunning my time, so we'll just leave that slide there for a few minutes to say how the city that was designed with the distances so that there would be shopping centers close to people, also made it so that shopping centers would be within the distance that a robot can reasonably walk or roll in 1 hour for the 1 hour delivery and back. So even if people think, I am not going to walk because the weather is terrible, as it is today, the robot doesn't mind, and the distance, it is just right. And also, you can see there the network, the grid road. Robots like repetition a lot, humans not so much, because when robots are driven by algorithms, if you design with repetition, if the robot knows how to navigate one of those squares in the map, the robot knows how to navigate all of them in a way. So that made it easy for them, even if it was not the intended purpose at first. So I will leave it there because I think I have grossly overrun my time. Thank you so much. But I just leave with that question. So how do we design for humans and robots at the same time so we don't become locked into designing just for robots and having an hyper-rational city that humans don't enjoy? That's all. Thank you. And Nick, I think I leave you the microphone so you tell us what goes next.
Absolutely. So I think general questions, we can take general questions first, but also do think about the workshop theme that comes up, future abilities. So if there's anything you'd like to ask our experts on that point.
And also the people online, if they put your questions in chat.
Yeah.
And we'll keep an eye on it.
Or questions in the room if there are any.
Oh, yeah.
So, thanks, Steve. The presentation was fascinating. You mentioned, almost as a throwaway, this idea of hive intelligence. How transferable is that technology from one of the kind of delivery robots to a wider public transportation policy, whereby multiple systems are integrated into one collective approach to this problem of restricted fixed transport routes?
Now, I'm not quite. Did the people online pick up that question?
You may need to repeat it, Steve.
Yes, it was just wondering whether the hive type approach of where you have artificial intelligence learning that can apply across, in this case, across the Starship robots, can that be applied to a higher level to a public transport system? I think that was the question.
Yeah, essentially multiple modes, so not just
across multiple modes.
Yeah.
I think this is a sort of big data thing that that a lot of the big IT companies are working on in terms of their information systems. You know, this happens all the time. Just from your from Google Maps or your journey planning apps are actually doing that a lot of the time, and they can automatically remember your journeys, and if somebody else is having a difficulty, if there's a problem, that will actually reroute you because it's been registered on the database system as well. So that this sort of hive multiple learning stuff is actually there within the journey planning apps that you have at the moment. The thing about the Starships is they don't, they're not terribly bright in the system, but they're bright enough to do their job. I quite often argue that that's my system, that's my approach professionally. And it's also an issue of, but you then open up all these questions about, are you actually contributing something towards something is sorry, I'm stumbling a bit, but it's the personal security side of things that comes into that as well. And are you willing to give away some personal security in terms of the quality of service you get in return? And for the journey planning apps, that is something which people seem to be very willing to do that. The benefit is worth the loss of personal information. And you have to have an assurance that the information you provide is not being abused, and hence you get this on every site when you go on. You want to tick in what the stuff is going to go through. I think that is emerging now into much wider systems. So on the public transport side, I think if you do start using a sort of demand responsive transport and even an Uber type service, there is actually machine learning going on there, because it then learns what you are like as an individual, and you start getting some suggestions as to what you're going to do, and whether possibly you don't need to leave that early, the traffic is okay, and you got somewhere too quick last time, so and if you let me just do that, then I can pick somebody else up on the way. I think those sort of things are like to happen. But quite how quickly that comes on board, I think, is another matter. But that sort of artificial intelligence trade-off, those sort of trade-offs are actually occurring at the moment. Perhaps we don't realise they are occurring at the moment. But if they actually give us a really substantial benefit without us feeling insecure or real insecurity, and that is actually a big question, and that is really a software design issue, a really important software design issue.
Comment.
Oh, there's a comment.
Yeah, so I can read out. So Julie asks, so the use of robots sounds amazing. I think these could be incredibly useful to help, but often using apps, etc., is something a lot of the older generations actually struggle with.
I strongly agree, but with the use of technology, but also with the physical use of technology, and that may be a design issue. Because when this happened, when the pandemic happened, I thought, oh, this will be very useful for people who are housebound. And this includes elderly people, people with disabilities, people with compromised immune systems. There is a broad category of people who are housebound, other than people like me who don't drive. And I thought of interviewing people from various organizations representing people that I consider, oh, they could use this. And a lot of them told me, I cannot physically use the robot. Because, for instance, if you had a bad back, the robot is, say, about this tall, say 60 centimeters or so, and you have to bend down to unload it. And they told us, this in itself is already an obstacle for me. Or for people who are, for instance, using a wheelchair or a walking aid, they told me, the robot, you cannot tell them, come to my door, because the robot doesn't know doors. You tell them, come to my postcode broadly. It may be 3 doors down. It may be across the road. And they told me, if I am on a walking aid, maybe the robot is just on the other side of the street, on the other side of the road, but I cannot get to it. It's not good for me. So those are issues in how we design the service, and also in how we design physically the robot, so that people who cannot bend down, for instance, can unload it. The current design doesn't allow that, but I understand that the company is also in talks with all these groups that I interviewed. not because of me. I would flatter myself if myself has it. So it is just that it's a very logical thing to think about. Not everyone can use this. How do we address it? And on a related line, Steve, the demand responsive transport, you're probably thinking of that one.
This is an interesting thing because this is part of these new redesigns have benefits and losses. There's some people they're more suitable for than others, and that's an example that Miguel was picking up there. In both Milton Keynes Connect and in the HeartsLink service, there is an alternative of simply a phone number to ring up to book the vehicle, so you don't have to use the app. That is actually very important because at the moment, the elderly and the less tech savvy are going to be among those who could disbenefit if you go to entirely to an app-based service. So actually the role of enablers who simplify the system, so you ring up, somebody answers the phone and they just do the booking for you on the phone. You can do that as a backup. That works for the people for MK Connect and for HeartsLinks. The other thing is that actually these sort of services, some of the people who gain the most are people with mobility difficulties who can't actually go all the way to a bus stop. And you can actually register your individual mobility needs so that if you can't move very far from your house, not too far from your front door, the bus will actually, instead of going to a pickup point, will actually come to your front door. And that applies, so you just basically register a mobility impairment with your account for MK Connect. I know that most carefully. And the service will adapt for your personal mobility needs. Whereas us who can run off to the pickup point, it won't actually do that. So there are ways of fitting this in, but it's important that, you know, this sort of design specification is actually very, very important. There are some things which will be sort of, you might say, transitional design issues, and some which are permanent. Transitionals might be a matter of learning issues about adapting to how you order vehicles or how you order your shopping, and a learning element to go in. And you can actually design your system so that it can be easy for you to learn, and build in people to help you in information systems. Whenever you're in a design transition, this is important. But there are some of the points that Miguel made, which are permanent differences, which you just have to accept that maybe you will have a more diverse transport and a more diverse delivery system. It won't be that robots will replace everything, or different types of robots will serve different types of market. So that's part of the transition that's likely to occur. I hope, Julie, that's sort of answered your question. And Julie is typing, actually. Yes, we're okay.
I was really taken by this idea of co-designing the robots.
Yeah.
Are there any other examples out there? It's been tried in other areas, co-designing the robots.
Okay, the question's about co-designing for humans and robots together. That's interesting. I think it might have happened in the hospital example we've seen. The people who make the Starship robots have actually designed a robot to run in hospitals to take medicines to the wards. Yeah, so those are designed so they can run along hospital corridors quite safely, avoid people. But also, I do notice they instead of being short and squat, they're tall and thin. So you can actually see them going along. They've also got red lights at the back. The semantics are quite interesting. They put red lights at the back, white lights at the front. They're not running on roads, but the semantics of the design are that people know that if this red light's going away, that's the rear of it, and the white light's at the front. So there's some interesting things like that. But also, it has batteries at the bottom, which provide ballast and weight, and actually carries the medicines at the top, so that you can just lift the medicines out easily. The nurses can lift the medicines out easily and don't have to bend down. So I would say that is a sort of that is a co-design for a co-design for a shared environment. Yeah.
Why would they not be applicable for roads?
These robots for the roads, this particular robot is not intelligent enough to cope with these real-time decisions. This is almost by design, because the robot has to be inexpensive, and because of that, it has very limited processing capabilities. You can even, I don't think I would feel comfortable deploying one of those robots in London, for instance, when people are trying to go to places in a rush. Milton Keynes, particularly the redways of Milton Keynes, which were built for leisure, are places when people can see, oh, that robot is struggling. I will just wander around it and it's all good. But if you are in a high-performance environment, you need an expensive robot, and you can build it. But these are not Boston Dynamic robots. They are meant to be affordable for grocery deliveries and also for the hospital. Because, and this makes me think, by the way, that we have to think about the systemic impacts of what we build. With robots, I stress about displacing workers from the gig economy. I think that the gig economy is not very good for workers. I think it is a bit exploitative. But who am I to tell to a worker, you know what, you shouldn't have that work. You are fired, a robot will do it instead. I don't like that kind of job, but it's not for me to tell you shouldn't have it. In hospitals, I feel a bit more comfortable about it, because I know that there is not enough people to do everything that needs to be done in hospitals. And if a robot is doing the very simple but important job of taking medication from one place to another, which needs either training or you need to trust the robot because it is medication. If a robot can do that, I feel good about those, because we are not destroying jobs there.
One follow-up question on that, and then maybe the last one. Sorry. I find it really interesting about that. Do you know if in Milton Keynes, due to the use of robots, have other deliveries decreased, like other ways of, like typical, grocery delivery van? Do you know? Has anyone done any?
Okay. The question is whether other forms of delivery have declined in Milton Keynes as a result of the robots.
Yeah.
Actually, I don't know the exact figures, but my feeling is that Milton Keynes is quite delivery focused. Overall, there is a mixture, quite a mixture of services. So you've got the Just Eat services. There's some new robotic services being introduced, which are parcel deliveries. So another specialist market is actually parcel deliveries using competing robot designs. It's not this lot. It's not the Starships moving into that market. It's another robotic company, but focusing on delivery of parcels. I think Milton Keynes has become a bit of a testbed area. It's built up a reputation as a bit of a testbed area. Starship robots are now operating in Northampton. They're operating, I think, in Camborne in Cambridge. They're also operating in Leeds. So having sorted things out in a much more benign environment for robots, the company have now learned enough to apply them in more challenging urban situations. Broadly, they are working in those other situations. They're learning how to effectively press buttons at Pelican crossings to go across busy roads. They do that electronically, and other bits and pieces like that. So that is happening. I think what you're going to probably get is a diversity of the delivery of the delivery markets, and I think the delivery market is actually an increasing one. That is that there is room for a number of models there, from the Ocado, the supermarket deliveries, once a week deliveries, through to the quick on demand ones, which is Just Eat, and the robots. And the robots are largely competing with the sort of Just Eat gig economy type area, rather than the big supermarkets. So there's some complementarity emerging there, I think.
If I may expand on that, I will start with some press release from the companies who do not believe me or not necessarily believe them. As an academic, sometimes I feel stressed about, oh, should I be reporting this? But sometimes that's the only source you have. And the company states that the robots are mostly replacing people driving to the shops to get milk, which is good from the perspective of sustainability, but because it is a 50-kilo robot instead of mobilizing 300 kilos of steel just to get 1 gallon of milk, 1 pint of milk. So the company states that they are not replacing delivery drivers, but replacing people driving to the shops. And now, going to what I know from research, is that in Milton Keynes, it would not be cost effective to have a delivery driver for a pint of milk. In places like London, they have bicycle couriers who would be able to do that sort of thing because of the higher density. And this is convenient because in London, as I said, the robots could not navigate a crowded London pavement, but they can navigate Milton Keynes. So it's a horses for courses kind of situation.
Do you think there might also be opening up like kind of new markets? Like, you know, I know when they first came around, everybody was, if they don't come out to my village, but if everyone that could was using them to get a bar of chocolate or something like that. And I know, you know, kids use them to get something when they're in the park and things that they wouldn't previously have done, but because they now can do it, are doing. So I wonder if there's an element of kind of just a different kind of affecting consumerism in a slightly different way.
If I may say, that's probably a work for us to brainstorm today. Not to say everyone has to work with robots because I like robots, but I will tell you what I brainstormed years ago, and I think we all can do a bit of those things. I was wondering, there is a lot of lonely people in Milton Keynes. One of my roommates at the time was working in the campaign against loneliness. And I was thinking, what if you could summon a robot to go for a walk with you? And I was thinking particularly of elderly people who don't have necessarily friends or who worry about going for a walk alone, because some of the footpaths in Milton Keynes can be very secluded. I sometimes have a bad back, and sometimes when I went for a walk on a bad back day, I had like, oh, cramp, I am stuck here. There's no one around. No, what am I going to do? And I just had to walk it off. But I thought, if I had a robot within me, it was that time I could say, robot, get help. And the robot's not where I am. It has a GPS, a sat-nav or something on it. So the robot could do it. Or I could just say, hey, robot, lovely day, isn't it? These robots are very sociable. They tell you, thank you for shopping with us. Or if they get stuck in the snow and you give them a little push, they tell you, thank you for helping. One of our friends, a very mischievous friend, Mauricio, once tried to stop the robot just to see what would happen. And the robot said, oh, I am working, please let me work. So I thought, I would like to go for a walk with this robot. Maybe I could tell, robot, tell me a joke, robot, sing, give me a song. So this,
They do give you a song.
Yes. So this is not quite what you asked, but I think this robot gives us permission to think, what else could we build with an inexpensive robot that knows how to recognize people, knows how to find its way around, can navigate the city with me. And this is what we thought about.
There is a sort of theme emerging out of our presentations. There's a lot of very clever artificial intelligence tech out there, which costs an awful lot to implement. And that includes the autonomous taxis. But there's an awful lot of readily available basic level of artificial intelligence that doesn't cost too much, but can actually offer immense benefits. And it's worthwhile exploring that. You seem to have gone to...
Yeah.
Good
Just
segment.
a
Yeah.
comfort break. Do you think it's right?
Perfect. So comfort break,
Yeah,
and
it feels quite right in here. Yeah.
should we say goodbye to the people online, or
Thank you.
you
Yeah.
said that they will join us for the workshop, right?
Yeah.
If they
Nick is picking that up on her machine.
perfect. In that case, I'll stop the cameras and microphones. Comfort break, and please you tell us when we are coming back, Nick.